Volume and surface area of composite shapes. So composite solids are made up of two or more common solids. So we know like triangular prisms, hemispheres, spheres, rectangular prisms, that sort of thing. The volume of a composite solid is calculated by adding or subtracting the volumes of each common solid. Well, we've done most of this work before. The first one says find the volume of this solid below. So there's a couple of ways of approaching it, but I'm going to approach it by find the volume. Volume equals area of the cross section times the height. Now if I have a look here, here is my cross section, okay? And the height is the thing that's making this look 3D. Here is the height. This is the side that's making it look 3D. So 20 is my height. Now to find the area of this shape, this L shape, I'm going to divide this into two parts. It's up to you how you see it. I'm going to see it as this rectangle here, which you can see is 10 by, this number can come in here, by 6. And this smaller rectangle here, which has one side that comes in here, is 4. And this side along here, well, if this whole thing is 15 and this much is 6, 15 minus 6 gives me 9. So going back to my area, my formula, the area is made up of this 10 by 6 shape, that rectangle, plus the 9 by 4 shape. That's the area part. And then the height part, we know that is 20. Multiply this by 20. And what we can do is we can pop that into our calculator and you get 1,920 centimetres cubed. Now, I didn't put this question in, but I think it's worthwhile that we have a look at this. Can we now try and find the surface area? So to find the surface area, once again, I have this front side. And I've already kind of found that area. Here it is up here. The 10 by 6 plus the 9 by 4. But in surface area, there's the front, and remember there's the other one hanging out here at the back. So I'm going to multiply that by 2. Now, the next thing I have is I've got this side here, which is 4 by 20. So I'm going to write that one down. And the next side I can see is this top here, which is 9 by 20. And then I've got this strange side here. Now, if this is 4, then this part here must be 6 because this whole side is 10. So 4 and 6 is 10. So this side must be 6 by 20. And then the top part here is 6 by 20. Now, we mustn't forget the bottom, which is 15 by 20. I could put that in brackets, that doesn't really matter. And don't forget I've got this back side here, which has a height of 10, and once again, this distance here is 20. So we can find our surface area by writing this out every single side that we can see, and it makes our life much easier. And if we do that, I'm fairly sure you must get an answer of 1,192 centimetres squared. A grain silo consists of a cylinder with a cone on top as shown. The diameter of the cylinder is 16 metres and its height, and we should really change this to 20 metres. And I said, what is the volume of the solid? But can we change this to what is the volume of the cylinder? Correct to 1 decimal place. Well, here is my cylinder, here. And we know that the diameter of the cylinder is 16 meters. So that means the radius must be 8. So volume equals pi r squared height, which is pi times 8 squared times the height, which is 20. And what I get is 4,021.2 meters cubed. The last one, the concrete block shown is a square prism with a cylindrical hole of diameter 10 centimeters drilled through it. So this one has a diameter of 10 centimeters drilled through it. What is the volume of the concrete block before drilling? So that's just asking us what is the volume of the block. So volume equals area times height. But because this is a rectangular or a square prism, it's just 30 by 30 by 12. So the three numbers that's making it look 3D, which is 1,800 centimeters cubed. Now let's have a look at part B. Part B says, what is the volume of the concrete block after drilling to the nearest centimeter cubed? Well, we've got the volume of this entire block, and we're taking out this little thing inside. So this inside is really a cylinder, which has a length of 12 or a height of 12, and it's got a radius of 5 because that is half of 10. So the volume is going to be, well, we had the volume of the whole thing, that which from the previous question is 10,800, and I'm going to take away the volume of my cylinder, which is pi times r squared, so that is 5 squared, times the height. Pi r squared height is the volume for a cylinder. So if I pick up my calculator, I get 9,857.522 and so on, which is 9,858 centimeters cubed, correct to the nearest centimeter. So I wanted the nearest centimeter. There is my cut. I look here, that's a 5, so I need to round up. So lastly, part C says, what percentage, correct to 1 decimal place, of the concrete was removed to make the hole? So it's telling you what to do. We're trying to find a percentage, and to have a percentage we need a fraction. And it's saying what percentage was removed, so what was removed, and you have to put that over the original amount, and then you multiply by 100 to change it to a percentage. So the volume that was removed is given in part B, which is 9,858. And we're going to divide that by 10,800, and we multiply by 100 to come up with our answer. So depending on how you do it, I got 8.726, which is just approximately equal to 8.7% correct to 1 decimal place. Have a go at the exercise. If you have any questions, you can ask me in class. Thanks for watching.